Welcome. Today we're diving into the world of data structures in Python programming. Data structures are essential tools that help us organize, manage, and store data efficiently. Whether you're a beginner or looking to brush up on your skills, understanding data structures is a must for writing effective Python code. In this video, we'll explore the basics, look at different types of data structures, and see how they're used in real-world programming. Let's start by understanding what data structures are and why they matter in Python. Data structures are specialized formats for organizing, processing, retrieving, and storing data. In Python, they allow us to handle large amounts of information efficiently and perform operations like searching, sorting, and updating data. Think of them as containers that help you keep your data tidy and accessible. The right data structure can make your code faster and easier to maintain. Now let's look at the built-in data structures Python offers and how they're used in everyday programming. Python provides several built-in data structures, each with its own strengths and use cases. The most common ones include lists, tuples, sets, and dictionaries. Lists are ordered and mutable, making them perfect for storing sequences of items. Tuples are similar but immutable, which means their contents can't be changed. Sets are collections of unique elements, while dictionaries store data as key-value pairs. Understanding when and how to use each type is crucial for writing efficient Python code. Start with lists, one of the most versatile data structures in Python. Lists can hold items of any type, including numbers, strings, and even other lists. They're ordered so you can access elements by their position, and they're mutable, meaning you can add, remove, or change items as needed. Lists are created using square brackets like this. MyList equals 1, 2, 3. They're great for storing sequences of data that may need to change during your program's execution. Python lists come with a variety of methods that make them incredibly useful. You can append new items, remove existing ones, or even sort the list. For example, using MyList, append4 adds a new element to the end. You can also use slicing to access parts of a list, like MyList13, which returns a sublist. Lists are flexible and widely used in Python for everything from storing user input to managing collections of objects. Tuples are similar to lists, but with one key difference: they're immutable. Once you create a tuple, you can't change its contents. This makes tuples ideal for storing data that shouldn't be modified, like coordinates or fixed settings. Tuples are created using parentheses, such as mytuple equals 1, 2, 3. They're also ordered so you can access elements by index, just like with lists. Tuples are often used for data integrity and as keys in dictionary. Tuples are best used when you want to ensure that your data remains unchanged throughout your program. For example, you might use a tuple to store the days of the week or the coordinates of a point on a graph. Because they're immutable, tuples can also be used as keys in dictionaries, unlike lists. This makes them valuable for situations where data integrity and consistency are important. Sets are another built-in data structure in Python, designed to store unique elements. They're unordered so the items don't have a specific position, and duplicates are automatically removed. Sets are great for tasks like removing duplicates from a list or checking for membership. You can create a set using curly braces like mySet123. Sets also support mathematical operations like union, intersection, and difference, making them powerful tools for data analysis. Working with sets in Python is straightforward. You can add elements using the add method and remove them with remove. Sets are especially useful for membership testing, like checking if an item exists in a collection. They're also handy for eliminating duplicates from lists. For example, converting a list to a set automatically removes any repeated values. Sets are efficient and often used in data cleaning and analysis tasks. Dictionaries are one of Python's most powerful data structures. They store data as key-value pairs, allowing you to quickly look up values based on a unique key. Dictionaries are created using curly braces like myDict equals name, Alice, age 25. They're mutable so you can add, remove, or update key-value pairs as needed. Dictionaries are perfect for storing structured data, such as user profiles or configuration settings. Accessing data in a dictionary is simple and efficient. You use the key to retrieve the corresponding value, like myDict name. You can also check if a key exists using the in keyword. Dictionaries support various methods such as keys, values, and items, which let you iterate over the data. This makes dictionaries ideal for tasks where you need to associate information, like mapping usernames to user IDs. So many options. How do you choose the right data structure? It depends on your needs. Use lists for ordered, changeable data, tuples for fixed, ordered data, sets for unique, unordered items, and dictionaries for key-value mappings. Picking the right structure can improve your program's speed and readability. As you gain experience, you'll develop an intuition for which structure fits each situation best. Python allows you to nest data structures within each other, creating complex and flexible data models. For example, you can have a list of dictionaries or a dictionary with lists as values. This is especially useful for representing structured data, like a database of users where each user has multiple attributes. Nested structures help you organize information in a way that mirrors real-world relationships. One of Python's strengths is its ability to easily iterate over data structures. You can use for loops to process each item in a list, tuple, set, or dictionary. This makes it simple to perform operations like filtering, transforming, or aggregating data. For example, you might loop through a list of numbers to calculate their sum, or iterate over a dictionary to print all key-value pairs. List comprehensions are a concise way to create lists in Python. They let you generate new lists by applying an expression to each item in an existing list, often with a condition. For example, x*2 for x in my list if x creates a new list of doubled values for positive numbers. List comprehensions are not only shorter but also often faster than traditional loops. Just like list comprehensions, Python supports dictionary comprehensions. These allow you to build dictionaries in a single line of code. For example, x*2 for x in range 5 creates a dictionary mapping numbers to their doubles. Dictionary comprehensions are useful for transforming or filtering key-value pairs efficiently. Lists in Python come with a variety of built-in methods that make them versatile. Some of the most commonly used methods include append, extend, insert, remove, pop, and sort. These methods allow you to add, combine, and rearrange items in your list with ease. Mastering these methods will help you manipulate data more effectively in your programs. Dictionaries also have powerful methods like get, update, pop, and clear. The get method retrieves a value for a given key, returning none if the key doesn't exist. Update lets you add or modify multiple key value pairs at once. Pop removes a key and returns its value, while clear empties the dictionary. Knowing these methods helps you manage structured data efficiently. Slicing is a powerful feature in Python that lets you extract parts of lists and tuples. By specifying a start and end index, you can create sublists or subtuples. For example, my list1 4 returns items from index 1 up to but not including index 4. Slicing is useful for breaking down data into manageable pieces or for copying parts of a sequence. Python allows you to unpack data structures, assigning their contents to multiple variables at once. For example, a b c equals 1, 2, 3 assigns 1 to a 2 to b, and 3 to c. This is especially handy when working with tuples or lists returned by functions. Unpacking makes your code cleaner and more readable, especially when dealing with structured data. Understanding the difference between mutable and immutable data structures is key in Python. Lists, sets, and dictionaries are mutable, meaning you can change their contents after creation. Tuples, on the other hand, are immutable and cannot be altered. This distinction affects how you use these structures, especially when passing them to functions or using them as dictionary keys. Copying data structures in Python requires attention. Assigning one list to another variable doesn't create a new list, both variables point to the same object. To create a true copy, use the copy method or slicing. This is important to avoid unexpected changes in your data, especially when working with mutable structures like lists and dictionaries. Python makes it easy to check if an item exists in a data structure using the in keyword. This works with lists, tuples, sets, and dictionaries for keys. Membership testing is fast and helps you write clear, concise code. For example, if Apple in my list checks if Apple is present in the list. This feature is especially useful for filtering and validation tasks. Sorting is a common operation in programming. Python provides the sort method for lists, which arranges items in ascending or descending order. You can also use the sorted function, which works with any iterable and returns a new sorted list. Sorting is useful for organizing data, preparing reports, or finding the highest or lowest values in a collection. Stacks are a type of data structure that follow the last in, first out LIFO principle. In Python, you can implement a stack using a list, using append to add items and pop to remove the last item. Stacks are useful for tasks like undo functionality, parsing expressions, and managing function calls. Understanding stacks helps you solve a variety of algorithmic problems. Queues are another important data structure operating on a first in, first out FIFO basis. In Python, you can use lists or the collections deck module to implement queues. Queues are ideal for managing tasks, processing data streams, or handling requests in order. They're widely used in programming for scheduling and resource management. A list can be used for queues. Python's collections deck is more efficient for adding and removing items from both ends. Decks provide fast appends and pops from either side, making them perfect for implementing queues and stacks. They're especially useful when you need to process data in both directions or manage large datasets efficiently. See how data structures work together in a practical example. Imagine building a user database. You might use a list to store user records, where each record is a dictionary containing details like name, email, and age. This combination allows you to easily add, search, and update user information, demonstrating the power of Python's flexible data structures. In working with large datasets, choosing the right data structure becomes even more important. Efficient structures like sets and dictionaries can dramatically speed up operations like searching and filtering. Python's built-in tools make it easy to process big data, whether you're analyzing logs, managing inventories, or handling user data at scale. Sometimes, built-in data structures aren't enough for your needs. Python allows you to create custom data structures using classes. By defining your own classes, you can build structures like linked lists, trees, or graphs tailored to your specific requirements. This opens up possibilities for solving complex problems and optimizing your programs. Linked list is a custom data structure where each element, called a node, contains data and a reference to the next node. Unlike lists, linked lists allow efficient insertion and removal of elements from any position. They're useful for implementing queues, stacks, and other dynamic data structures. Understanding linked lists is key for advanced programming tasks. Trees are another advanced data structure, ideal for representing hierarchical data like file systems or organizational charts. Each node in a tree can have multiple child nodes forming branches. Trees are used in algorithms for searching, sorting, and organizing data efficiently. Python's flexibility allows you to implement various types of trees, such as binary trees or decision trees. Graphs are powerful data structures for modeling complex relationships between objects. In a graph, nodes represent entities and edges represent connections. Graphs are used in social networks, navigation systems, and recommendation engines. Python's libraries and custom classes make it possible to build and analyze graphs for a wide range of applications. Choosing the right data structure isn't just about convenience, it also affects your program's performance. Lists are fast for indexed access but slow for searching large datasets. Sets and dictionaries offer fast lookups while linked lists excel at insertions and deletions. Understanding these trade-offs helps you write efficient, scalable code. Different data structures use memory in different ways. Lists and dictionaries can grow dynamically, but they may use more memory than necessary. Tuples are more memory efficient because they're immutable. When working with large datasets or limited resources, it's important to consider the memory footprint of your chosen data structure. Many algorithms rely on data structures for efficiency. Searching, sorting, and traversing data are common operations that benefit from the right structure. For example, binary search works best with sorted lists while breadth-first search is used with graphs. Mastering these algorithms will help you solve complex programming challenges. Data structures are everywhere in real-world programming. From managing user data in web applications to processing transactions in financial systems, the right data structure makes all the difference. Python's versatility and rich set of built-in structures make it a top choice for developers in every industry. Debugging is an essential skill when working with data structures. Python's print, function, and built-in debugging tools help you inspect the contents of your lists, dictionaries, and other structures. By understanding how your data is organized, you can quickly identify and fix bugs, ensuring your programs run smoothly. Testing is crucial for reliable programs. Python's Unitest and PyTest libraries make it easy to write tests for functions that use data structures. By testing edge cases and typical scenarios, you can catch errors early and ensure your code behaves as expected. Good testing practices lead to more robust and maintainable software. Clear documentation helps you and others understand how your data structures work. Use comments and docstrings to explain the purpose and usage of your code. Well-documented data structures are easier to maintain, debug, and extend, especially in larger projects or when working with a team. There are many resources available to help you master data structures in Python. Online tutorials, books, and coding platforms offer exercises and challenges to build your skills. Practice is key. Try implementing different structures and solving problems to deepen your understanding and confidence. Even experienced programmers can make mistakes with data structures. Common pitfalls include using the wrong structure for a task, forgetting about mutability, or misunderstanding how references work. By being aware of these issues and testing your code thoroughly, you can avoid bugs and write more reliable programs. Optimization is about making your code run faster and use fewer resources. Selecting the right data structure is a big part of this. Profile your code to find bottlenecks and consider alternative structures or algorithms if needed. Efficient data structures can make a huge difference in performance, especially for large or complex programs. Python is constantly evolving with new features and improvements added regularly. Stay up to date with the latest developments in data structures and best practices by following official documentation, blogs, and community forums. Continuous learning ensures you're always writing modern, efficient Python code. Congratulations, you've taken a comprehensive tour of data structures in Python programming. From basic lists and dictionaries to advanced structures like stacks and trees, you now have the foundation to write efficient, organized code. Keep practicing, explore more complex examples, and apply these concepts to your own projects. The more you use data structures, the more powerful your Python skills will become.